Today's problem is palindrome substrings. This is a hard problem. Average solution time, 30 minutes. Given a string S, count all palindromic substrings present in the string. The length of the palindromic substring must be greater than or equal to 2. In other words, we're not counting individual letters as being palindromes. So a substring is palindromic, if it reads the same forwards and backwards. All right, so here's an example. What are the palindromic substrings? A, B, A works, A, A works, B, A, B works. Okay, we have A, 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 A. What do we have here? Oh, a lot. B, B, A, B, B, A, E, A, E, A, E. The size of the string is going to be between 2 and 5 times 10 to the third. That's not a lot. 5,000. S contains only lowercase English letters, characters, expected complexities. Okay. N squared. That's okay because, for input sizes on the order of 10 to the third, it should be okay. Things about the size, probably. Well, what is oh, I see. Yeah. So if there are no palindromic substrings, you would return 0. It's probably good to clarify. Will the string possibly be empty? Will it possibly contain less than 2 characters? What else? Company tags. I've heard of most of those. Topic tags. Dynamic programming. Yes. Okay. I'll mention here that there is an algorithm called Maneker's algorithm. It finds palindromic substrings very efficiently, but it's not an easy algorithm, and it's not, to me, a super intuitive algorithm. You're not going to be asked to do that in an interview, but it's linear. The dynamic programming solution is O of n squared. What else? And it's much more intuitive to me. It's based on the concept that a string of characters from index I to index j is a palindrome if the characters at I and j are equal and the substring from I plus 1 to j minus 1 is a palindrome. That's the way we build up the DP table. Okay, so let's take a look at this. Let me pull it over a little, and let me pull this over a little. I want that example with the A, B. Oh, well, but then there's no room. All right. So let me sketch out a DP table, and then we'll come back. All right. So let's go through the algorithm. I made a couple of simplifications here. I'll talk about those in a minute. But okay. So n is the length of the string. RES, result. Result is initially, and that isn't going to stack up very well, is it? Let's do it like this. RES equals 0. Boolean. This is a Boolean array. I know I put numbers in it, but to do a Boolean array of the dimensions of the string length, which in this case is 5. The simplifications are, it's easier to draw zeros and ones quickly than it is to to write T's and F's. So the 0 will represent false, 1 will represent true. I also didn't fill in the lower portion of the table because we're not going to use it anyway. All right, first thing we do here is for I goes from 0 to n, dp I equals true. So every single character is a palindrome. We're not going to count it as a palindrome, but it is a palindrome. For the sake of recognizing other palindromes, it is a palindrome. So let's see if we can get rid of this, 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 and this. So what we're talking about is 0, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. All right, those are all palindromes, right? Okay. Next, any two-character string is a palindrome if they are the same character. So I is going to go from 0 to n minus 1, not to n, because we are going to add 1 to it here. So dp I plus 1. Let's see. Okay, so that actually is going to be these characters right here. All right. So 0 is the character at 0 equal to the character at 1. That's AB. No, it's not. Okay. Is B equal to A? No. Is A equal to A? Yes. Is A equal to B? No. Okay. It just occurred to me that in the process of identifying two-character palindromes, I forgot to increment res, because we did find a two-character palindrome. It's the AA. So that is going to go to 1. All right. Now we are looking for palindromes of length greater than 2. All right. So again, we look at gaps of 2. So gap starts out at 2. I starts out at 0. J is I plus gap, which is 2. So we can look at 0, 2. Is 0 equal to 2? At index 0, A and A, yes. And then we look at the intermediate string and see, is that a palindrome? dp I plus 1, J minus 1. So actually that is, you know what, let me erase, because the gaps of 2 are actually on this diagonal here. All right, so first of all, we're looking at this, 0, 2, and then we're looking at dpi plus 1, which is 1, j minus 1 is 1, which is this one. So it's actually the table cell diagonally down and to the left. Okay? Is 0 equal to 2? Yes. Is the intermediate string a palindrome? Yes. So that is a palindrome, and we'll increment res. All right? Now, I is going to go to 1. J is going to go to 3. Index 1, index 3. Are those equal? No. We are going to go to 2. Oops, no. No. You're going to go to 2 and 4. 2 and 4. A, 2 and 4. Are those equal? No. So that's done. All right. let me erase these because that's where we are now. Gap is now going to go to 3. Gap is 3. Can I erase this stuff? All right. So I starts out at 0. I starts out at 0. J starts out as at I plus gap, which is 3. 0, 3. Are those equal? 0, 3. Yes. So then we look at what is it? 0, 3. It would be 1, 2. 1, 2. It's right here. Again, it's diagonally down and to the left. But the intermediate string between 0 and 3 is not a palindrome. So that is not a palindrome. All right. So this will go to 1, and then this will go to 4. How about 1 and 4? 1 equals 4. Is the intermediate string a palindrome? Yes, it is. So get that, and we'll also increment res. All right, and finally, we are here. Okay, get rid of that. Get rid of that. Gap is going to go to 4. This starts at 0, and this is 4. The letters at 0 and 4, are those equal? They are not. All right, so we're done. We have 3 palindromes. Is that the right answer? I believe I can scroll this. Wait, no, I think I can. AB, AAB, and 3 is the, yeah, so that's what we're looking for. All right, so that's it. It's dynamic programming problem. It's probably on the lower end of the hard scale, really. Let's get rid of the letters and try and run this. Annotations. Yes. Yeah, you don't have to remind me of that. Okay. Let me scoot this back. All right. Oh, you know what? I don't think I even did a compile and run on that. Oh, okay. Okay. Dynamic programming bottom up. And that's it. Please like the video, subscribe. I'll send you problems of the day every weekday. And we'll see you next time.